Alright, while that first video is processing, I came back to record the second part. And we're gonna go over now the future value function. Okay, so the first two pages, the present value, we went over those together. The future value function, well, we use it when we try to figure out how much money am I gonna have in the future. Okay, so let's do these ones together now. Future value is asking you for very similar input. It's asking you for the rate and per payment amount each month. And those so far have been $0 for us. And the present value today, right? All right, so let's look at number one together. Find the savings plan balance after 3 years, highlighting, with an APR of 6%, and monthly payment of $200. Do not round until final answer, then round to the nearest cent as needed. Now that rounding rule is important if you're using a formula and you're typing things into a calculator, like in the middle of it. But for us, that rounding doesn't apply because we know our Excel will be able to figure this out for us. Now, what part of what we just read is telling us that we must use the see if I'm even recording. Yeah, I'm recording. What part is asking us to find the future value? Find the savings plan balance after 3 years, right? So not today, but how much money am I gonna have in 3 days, right? And 3 years, right? Not 3 days. So let's go ahead and use that future value function and let's carefully type in our inputs together, okay? Now, type in equal sign future value. Now let's type in the rate. Now rate is 6%, but notice that we're making monthly payments. So divide this by 12, okay? And then N per. How many months do you have in 3 years? That's the question. To figure that out, you will do number of years times the month, what's it called? The number 4 compounding period per year. So N here is 12. So do 3 times 12 there. Now this one, what about payment? Now we're making payment this time, right? It's been 0 so far, but for this one, we're gonna go ahead and deposit $200 every month. So type in 200 in the third entry for payment amount of 200. Now, what about present value? Now, think about this. How much money do we have in the savings plans today? Didn't say it, right? Safe to assume $0. We don't have any money right now. So no money, but if I start saving $200 every month for the next 3 years with an APR of 6%, how much money am I going to have in the next 3 years, right? That's the question. So let's go ahead and open up the Excel calculator. And then I'm going to type this in, what I just entered. Equal sign, future value. There's the function. 6% divided by 12, 3 times 12, 200, 0. And then if I hit enter, that's going to give me the answer. The answer is, wow, look, if I save $200 for the next 3 years, I'm going to end up with $7,867.22, $7,867.22. And of course, that's more than simply doing 200 times 200 times 12 times 3. Because if I'm not gaining any interest, I will only get $7,200. Still good, but you see how we made how many extra dollars for putting it in an account that's earning, I think I know what's going on. That's earning 6% APR. We got $667 more. See, that's good. So let me go ahead and bring my answers in from the Excels over here. Ta-da! So this is what I entered in Excel, right? That's the formula that I entered. And this is the answer that it gave for us, right? So that's going to be the future value of this savings plan. Okay? All right, let's look at number 2. So we're planning for future in these future value examples. And retirement is a big one, right? At age 24, someone sets up an IRA, individual retirement account. Very good. Only 24, but already thinking about retiring, right? That's good. Start early because you see how over the time your money, your savings, your deposits, your investment will grow with interest. So the sooner you start, the better this will be. Like when I first got a job, I know one of my church members, he was doing some of these financial stuff. So I didn't know anything back then, but I was like, all right, I'll sign up. So I've been paying for like the last 12, 13 years, and without even me realizing, because I'm not making big payments, but that money is just growing for me. So I'm excited for my retirement. But start saving early, like this person at age 24, setting up an IRA. Now, let me go ahead and highlight some of these things. APR of what? 5%. At the end of each month, he deposits $130 in the account. That's what I kind of did. I paid about like $150 every month. How much will the IRA contain when he retires at age 64? Guys, I'm going to have to highlight two numbers here. And then if you notice, these two numbers are about his age, right? So the question will be this. How long is this investment period, right? How long is he paying this deposit of $130 for? So if he's retiring at 68, you can do 68 minus 24 and figure out that he'll be doing this retirement account, the savings account for the next 44 years. So we're looking at 44-year investment. Okay, that's long. Compare that amount to the total deposits made over the time period. Now, that one will be very easy. Now, why don't we do that together right now? Without gaining any interest, guys, no interest. If he just puts in $130, like, oh, hold on, let me try to make it prettier. I'm sorry, I want everything to be like good looking. He's putting how much? $130. He's putting $130 every month. So what am I going to multiply that by? First, I'm going to multiply that by 12, right? But how many years is he doing this for? I got 44 years, and the 44 is really from 68, the age he's retiring, minus how old he is today. So if I do that, notice this doesn't have any kind of interest going on. This is completely out of his pocket. How much is he paying out of his pocket? That's what I'm trying to figure out right now. So let me go in, and that's a simple multiplications. I don't really need Excel or anything. I'm just typing this in my tiny calculator on my hand. 130 times 12 times 44. So how much money is he putting out of his pocket? I mean, taking out of his pocket to put in this individual retirement account? He's only putting $68,640. So, guys, think about this though. Is that enough money for somebody to retire on? I mean, if he saves and if he doesn't use a lot, but a car nowadays is like that expensive. So what if his roof breaks down, something horrible that shouldn't happen, but like, if he needs to change or get a new water heater in his house, then, he may need to save more than that. So, well, the thing is, that's how much money he's depositing it out of his pocket. And that's before all this interest and all this compounding comes in, right? So why don't we go ahead and figure out how much he's actually going to have? Because that's the money that he's paying, but that's not the money he's going to end up having, All right, so let's go ahead and figure out this by using the future value function. Why do you think we're using the future value function? Because we want to know how much money he will have in the future in 44 years from now. So I'm going to go ahead and just copy down this kind of, what we need to type. So future value, and first thing that we need to give them is rate. What's the rate? It's 5%, but he's making monthly payments, isn't he? Yeah, each month. Divide that by what number? 12. Monthly payment, we're going to say he's getting monthly compounding. Now, end part. How many years is he doing this for? He's doing this for 68 minus 24 years, but each year has 12 compounding period. So this looks a little bit confusing, but that's really 44 times 12. 44 times 12 because we want to know how many months we have in 44 years. And I got 44 because his plan is to retire at 68 and he's now 24, okay? All right, now what about the payment amount? He's depositing at how much? $130 every month. And the present value of his IRA is 0. He doesn't have any money in his account right now. He's just starting, okay? So that's what I'm going to do. And we're going to see a very good news for John, or what's his name? I don't know, for Sue maybe. All right, ready to type this in together? Go to Excel. Let me delete some of these things. Type in equal sign, future value, 5% divided by 12 comma, and 68 minus 24 in a parenthesis because I want my Excel to not mess up on the order of operation. Or you can simply do 44 if you want. Because the thing is, I don't know if the Excel will be okay of me using a parenthesis in a parenthesis, but I'm going to try. If they're not happy, I'll just change that number to 44. 130, comma, 0. Hit enter. Ta-da! So this is what I typed in Excel. I will screenshot that for those of you who never watched my video. I don't know how you're doing this. Hit enter. And that's the amount. And I'm just gonna first copy this and then I'll take a look into this when I have this on my screen over here, okay? All right, so this is what I entered in Excel, and this is the answer it gave me. Let me put this in my blank over there. This one, I'll put it over here. And let's talk about how amazing this is. Because, you know, the money that this person is actually paying out of pocket is $68,640. That's it. And if he's just putting, you know, $130 into his piggy bank or, you know, putting it in his backyard without earning any interest, that's the only money, that's the amount of money he's going to have when he's 68. But if he invests, if he put these in an individual retirement account that's giving him 5% APR, then how much money is he going to have in this individual retirement account? He's going to have $249,096.35. That's amazing. See? So when you guys get a job, you know, and when your employer says, oh, we'll match your 401k and we'll pay you, sign up for those, okay? Make sure you start saving early so that by the time we're like 70, probably don't want to work until 70 something, but some people do. But I want to retire when I'm like 64 or 63 or maybe early, you know, that'll be great. But we want to be able to have some good amount of money in our checking account to be able to start going on cruises and stuff instead of working all the time. So yes, I think this section is just so fun to think about. I know some of us are still so young, but it's great to think about early, right? Now, I think that's it for future. Oh, you know what? There's another one. Yeah, I think I just a little too excited for this section right here. But let's do one more. A bigger problem. Number 3 has part A, B, C. And then I'll stop the video and I will record another one for payment function. Okay? And thank you for your patience. I don't think I was going to be able to do this in Zoom meeting in hour and 15 minutes. So thank you for watching, spending extra time this week to learn about these functions this week, okay? All right, last one of the future value. Let's read this. The following pair of investment plans are identical, except for a small difference in interest rate. Okay. Compute the balance in the account after 10 years and 30 years. Oh, look. I'm going to highlight this part. Compute the balance in the account after 10 years and 30 years. 10 and 30 are good numbers that I'm going to need to use. But what they are asking you to find is the balance in the future. So that's why we're going to use the future value function here. Round to the nearest cent as needed. Discuss the difference. Sue is investing $1,000 in a savings account. So $1,000 is the amount that she's depositing today. And that account is earning 3.5% compounded annually. You know what? Let me highlight this whole part. Compounded annually. All right. And Noah invests 10,000. Oh no, not 10,000. $1,000 in a different savings account. But he's getting a slightly better deal. Sue better go to that bank. Noah is getting 3.75% compounded annually. But you know, they're not that big difference, right? Only what 0.25% difference here. But what we are gonna do is we're gonna find the balance after 10 years and 30 years, and how the small difference in interest rate can result in how much difference in the future. So let's see. First, after 10 years, Sue will have a balance of approximately, let's find out the future value of Sue's investment. Future value, first give them the rate. 3.5%, I was trying to see what I need to divide by. Compounded annually. I don't need to divide that by anything. 3.5%. If you are dividing by a number, what's that number? 1, right? So 3.5. And then the next number is the number of compounding period. We're looking for 10-year, right? So I'm going to enter 10. And I forgot what the third entry was. Let me go up and copy down the key. See, they're asking for like 4 inputs in these functions. I don't usually go around memorizing these order. So I'm just going to go ahead and copy this. All right. So I did, let me try to make the same size at least so that I can make them both size 12 font. Both. All right. So rate is 3.5%. NPAR is 10. Payment is Sue making any payments? No, right? Sue's not making any payments, but her present value is $1,000. You see, she's putting $1,000 in today into her savings account. So if I go ahead and enter this into my Excel, I'll be able to figure out what her future value is going to be. And I just copied that over here. And if I enter, I get 1410.60. So she's going to have $1,410.60. And that's going to be my answer over here. So let me put that over here. I'll have to delete all these tiny screenshots after recording this video later. Alrighty, so that's how much Sue's going to have. Alright, what's next? After 30 years, Sue will have a balance of approximately, now you know nothing really changed except for what? Except for the number of compounding period, which is now 30 years. So I did just copy the same exact thing, but I just changed the 10 to 30, okay? So her investment, because in 10 years, it didn't grow too much. Like, it only went up $410.60. But what about in 30 years? If I change that to 30 this time, her balance after 30 years is going to be $2,806.79. I mean, after seeing somebody's IRA amount, I mean, this isn't too much, but still. Her investment isn't too big, right? All right, so that's the amount she's going to have after 30 years. Now, what else are we doing? Now, I read another name. There is also Noah. Noah is my son. All right, let's do the same exact thing for Noah. After 10 years, guys, I'm going to go ahead and just copy this because it's going to be exactly the same. But Noah's interest rate was what? 3.75%, right? So let's figure out Noah's balance after 10 years first. And the entry, as you can see, 3.75%, comma 10, comma 0, comma 1,000. Because they had almost the same exact investment except for a small, tiny little difference in their interest rate. If I hit enter, I got the answer to be, Noah will have $1,445.04. Let me go ahead and write that answer down. It's the amount Oh no. That's the amount that Noah will have after 10 years. And later we're going to compare these amounts. But for right now, let me just find these answers, okay? So what about in 30 years? Now I'm keeping everything else the same over here, but I'm going to go ahead and change that 10 years to what year? 30 years. And let's figure out how much Noah will have in 30 years with that 3.75 interest rate. Hit enter. Oh, he's going to have $3,017.47. All right, let me go ahead and bring that answer over here. And once you write all these answers, we can compare them, because I think that was the goal of this question. We're actually making comparison. All right. And we know that Noah must have more money because, I mean, it was not that big, but his interest rate was slightly higher than Sue's, right? All right, so I got my numbers written down. And you know how I got these numbers, right? All right, now what? Comparing part. Part C. After 10 years, Noah will have blank dollars or blank percent more than Sue. Now, guys, this is asking us to find the absolute difference and the relative difference, right? The first one, how much more money will Noah have? The amount that Noah have is this amount minus how much Sue has in 10 years, that amount. And if I subtract these two, I will get my answer to be, let me see, 1445.04 minus 1410.60. Sue will only have, Noah will only have $34.44 more than Sue in 10 years. And for me, that's not that big. That's like, it's like just $30. But that's still more, right? But now let's do the relative change, right? They want you to find the percentage. So to find the relative change, you know what to do. You can do subtract these two values, find the absolute difference of 1,445.04 minus 1,410.60, and you divide that by 1410.60. And then you want to give them the percentage, don't you? So multiply this number by 100. That's how we find the relative change. And if you we already kind of subtracted the numerator, didn't we? And we got the numerator, the subtraction to give us what number? 34.44. So do this. Do 34.44 divided by 1410. Hold on a second. I shouldn't have a random comma over there. I should have a comma after 1. Okay, that's better. 1410.60, and then multiply that by 100, and you will get approximately 2.44. And they said don't round it around to the 2 decimal places. The next number for me was 441, so I'm going to go ahead and stop right there and tell them the answer is 2.44. Okay, the answer is 2.44% more than Sue. So after finding the future values, C and D, part C and D are just asking you to find the relative, you know, I should name these. The second one that we found was relative difference. And the first one that we found was absolute difference. You had that on your final exam review problems, right? So it's a great review for us to go over those. All right, now let's do the same exact thing using the balances after 30 years, okay? What do you think? It's gonna be more, right? Because after that 10-year period, Noah's money grew more, and well, Sue's money also grew too, but let's go ahead and do the same thing. So let me do the absolute difference first. Absolute difference in the next 30 years equals, I need two numbers. How much did Noah have in 30 years? That number was 30 17.47 minus, and then how much Sue had in 30 years? 2806.79. So the absolute difference in 30 years is going to be 17.47 minus 2806.79. And that comes out to be $210.68. So Sue will have, Noah will have that much more money than Sue in 30 years. So that's what we just found is called a relative difference. Now it's time for us to find the, we just found absolute difference, but let's go ahead and find the relative difference. And I'm just going to go ahead and copy this line above and just start typing. All right, for relative difference, you need to subtract to find the absolute difference on the numerator, and you divide by, remember, we divide by what we subtract, right? Or the original value, or the value that we're comparing to, comparing by, is that the right way of saying it? But I just always do it as the relative difference or relative change. I divide by what I subtract. All right, so if I do that, I will get, the numerator we already subtracted, didn't we? We subtracted and got $210.68. And I'm going to divide that amount by 2806.79. And then we're going to multiply that by 100. So let's see, what's that answer going to be? Divide that by 2806.79, multiply by 100. And since those are simple calculations, I'm just doing them on my handheld calculator. And that came out to be 7.51%. 7.51%. Okay? 7.51. So notice how this difference got bigger. Right? You notice how this difference got bigger from 10 years to 30 years, and that's gonna continue happening, right? So that tiny little difference in the interest rate over the 30 years, Noah will have $210.68, and that's 7.5% more than what Sue has in the next 30 years. So sort of like an application problem that took us more than just finding the future value, where we had to compare by finding the absolute difference and relative difference. But that's a great review of the final exam problems, right? So I know as you guys are taking your final exam review quiz, the matching problem on number 6 is grading as either 0 or 6. 0 or 6 points, all or nothing. So I've been going back to add some partial credits, but that's that. I will come back. I'm going to stop the video now, and then I will re-record the part with payment function. And this one will lead nicely into our project 2, step number 3, okay? All right, I'll be back.